Students, welcome once again to the Aval Academy of Education. In today's video, we are going to start here with ICSE Class 8 Physics. Book is again your Concise Physics by Selina Publications, right? Chapter we are going to do here is force and pressure, that is chapter 3rd. We are going to discuss here with exercise portion of this chapter. So students, first question in your book is define force, state its SI unit. So students, force is what? Force is a push or pull which tends to result in a movement or change in size or shape of the body. Tends to result in movement or change in size or shape of the body, right? This is definition of force. And what is SI unit of force? SI unit of force is Newton, which is named after its scientist or discoverer, that is Isaac Newton. You already know, right? Who gave the laws of motion, right? Now state two effects of, this is question number 2, state two effects of a force when applied on a body. So when we apply a force on body, it will make so for example, a moving car slows down on applying brakes on it. This is the effect of force. A push on a swinging girl speeds up her swing. When we give her more push with more force, so it will speed up, right? Question 3rd is, how does the effect of a force differ when it is applied on a rigid body and on a non-rigid body? So rigid body is hard, like rubber string. On stretching a rubber string, its length increases, and non-rigid body like a tube of gum, its shape changes, right? On squeezing a tube of gum, its shape changes. Effect of force on a rigid body like rubber string, its length increases, and effect of force on a non-rigid body like a tube of gum, its shape will change. It will take the change of your fist. Question 4. State the effect of force F in each of the following diagrams A and B. So here is the diagram 3.32. This is the force F. This is ball. It is applied on ball. And this is the force F is on a wheel which is pivoted here, right? So in figure A, when we apply force, the ball moves on pushing, that is by applying force it moves in the forward direction. In this direction it will move. And in figure B, since the body is pivoted here, so on applying force it will begin to turn about the pivoted point, say O, right? Pivoted point, say O, which is called the axis of rotation. So if we will keep on applying force here, it will turn, right? So next question is define moment of force. What is moment of force? Moment of force is defined as a product of magnitude of the force and the perpendicular distance of the force from the pivoted point, right? So moment of force is force into perpendicular distance of force, right? So this is its formula. Moment of force is force into perpendicular distance of force. So now we will move on to the question 6. So question 6 is state SI unit of moment of force. So SI unit of moment of force is Newton and that of distance is meter. So the SI unit of force will become Newton into meter, that is Newton meter. This is the SI unit of moment of force, right? It is written in short form, that is Nm, right? So question 7 is state two factors which affect moment of force. So we have two factors which affect moment of force are: number 1, the magnitude of force, the perpendicular distance of force from the pivoted point, right? So like in for example in this figure we will see the perpendicular distance here, right? We will say Vp. So the magnitude of force, the force, how force is applied, and the perpendicular distance from where up to which point the force is applied. Now we will move on to the next question, that is question number 8. It is given here in figure 3.3. This is figure 3.3. A force F is applied in a direction passing through the pivoted point O of the body. Will the body rotate? Give reason to support your answer. So here students, the body will not rotate. Why? Because the turning effect, as we know, force into perpendicular distance, we have just read on the previous page, force into perpendicular distance of the force from the pivoted point, right? So here the distance is not perpendicular. So here F, if force applied, it will multiplied perpendicular distance would be 0, because here the force is parallel to the point of application. So here there is no perpendicular distance, the point of parallel to the point of application of force, right? So hence the body will not move. This is the reason why the body will not move, because here the force is parallel to the point of application of force, right? Now we will move on to the next question, that is question number 9. Here write the expression for moment of force about a axis of given rotation. So this is the answer. Moment of force would be equal to force into perpendicular distance. We have just read on the previous page, right? Next is state any one way to decrease the moment of a given force about a given axis of rotation. So the one reason could be, one way could be, if we decrease the perpendicular distance of force from a given axis of rotation, so moment of force will be decreased, right? It can be decreased by decreasing the perpendicular distance of force from a given axis of rotation, right? So now we will move on to question number 11. What is question number 11 is state one way to obtain greater moment of a given force about a given axis of rotation. So here it was decreased. Here greater moment of given force about a given axis of rotation can be obtained, can be obtained by, here it would be written by increasing the perpendicular distance. Here perpendicular distance was decreased, here it will be increased. Perpendicular distance of force from where? From the axis of rotation, so that the given force may provide maximum torque to turn the body. The more will be the force applied, the more the body will be turned. So question number 12. What do you mean by clockwise and anti-clockwise movement of force? So clockwise movement, as its name is reflecting, if the effect on the body is to turn it clockwise, the moment of force is called clockwise, and it is always taken negative. And anti-clockwise moment of force, if the effect on the body is to turn it anti-clockwise, the moment of force is anti-clockwise and it is taken as positive, right? So for clockwise movement, we can see this figure like this. If suppose we apply force here, F is applied here, then the body will turn here like this, like this, like this. So it is clockwise moment of force, and it always negative. So anti-clockwise, if we, this is a disc, if we apply the force here, F is here, applied here, it is in anti-clockwise direction, so this is anti-clockwise, right? This is always positive, right students? So this was clockwise and anti-clockwise movement of force. Let us move on to the next question. Question 13, that is explain the following. Why the spanner or wrench has a long handle? Because it is made long to produce large turning effect by applying a small force at the end of its table, right? With large handle you can take work by applying small force, right? Spanner or wrench, the tool used by the plumbers while repairing your taps, right? The steering wheel of a vehicle is of large diameter because to turn the steering wheel in a vehicle, the driver applies force at a point on the rim of the wheel to produce a large turning effect by a small force. This is not force, this is force, F-O-R-C, force applied at the steering wheel, right? So the diameter of the steering wheel is large for application of small force, right? Now question number 13C. The hand grinder is provided with a handle near the rim. So the reason behind this is like the reason behind the steering wheel. Near the floor grinder is provided with a handle near the rim that is as maximum distance from the center, so that it can easily be rotated above the iron pivot, right at the center by applying a small force at the handle, right students? Now we'll move on to the next. Next is D. It is easier to open the door by pushing it at its free end. So it is easier because a small force at a larger perpendicular distance produces the required turning effect of force to open or shut the door. Right? When we push it, we applies a smaller force by at a larger perpendicular distance. So the larger the perpendicular distance, so larger would be the turning effect of force to open or shut the door. Right? Question 13e. A porter turns his wheel by applying a force through the stick near the rim of the wheel. So reason behind it is by applying the smaller force at a larger perpendicular distance, the porter produces required turning effect to rotate the wheel. Right? The larger the perpendicular distance, the larger will be effect of force. Next is, what is thrust? So thrust, it is the force that acts normally on a surface. Right? Thrust, pressure. Question 15. State the unit of thrust. The unit of thrust are kilogram force kgf and gram force gf and Newton. There are three units of thrust: kilogram force, gram force and Newton. So here it is the relation between these three. What is the relation? So 1 kgf is equal to 1000 gf. Right? 1 kgf is equal to 10 Newton. This is nearly, right? And 1 Newton is equal to 100 gf. This is also nearly equal to 100 gf. Right? Now next question. On what factors does the effect of thrust on a surface depends? So the effect of thrust depends on the area of the surface on which it acts. If the area of a surface on which thrust acts is small, the effect of thrust will be larger. Smaller the area of surface area of the object, larger will be the thrust, and if the area is larger, the effect of thrust will be smaller. Right? Question number 17 is, define the term pressure. So what is pressure? Pressure is defined as the thrust per unit area, and this pressure is equal to thrust upon area. Right? So and it's stated SI unit. The SI unit is Newton meter. This is not 2, this is Newton meter square. I am writing it here, Newton per meter square. Right? Or it is also called Pascal. Question number 18 is, how is thrust related to pressure? So this is question number 18. The effect of thrust is expressed in terms of pressure. Right? This is the main thing. More the effect of a given thrust on a surface, more is the pressure on the surface, and if less is the effect of thrust on a surface, less is the pressure on the surface. Right? So question number 19. Name two factors on which pressure on a surface depends. So the pressure on a surface depends mainly two factors, as we have read earlier in earlier questions: the area of the surface on which the thrust acts, and on the magnitude of the thrust acting on the surface. Magnitude means how much thrust has been applied. So question number 20 is answered here. When does a man exert more pressure on the floor, while standing or while walking? So a man exerts more pressure on the floor while walking because thrust equal to our weight acts on a smaller area, so exerts more pressure. So students, while walking, thrust equal to our weight acts on smaller area on which our foot or our feet resides. So area is small, so pressure would be more. If the area is small, the pressure would be more, right? So this is question 21 here. Why do camels or elephants have broad feet? Because on applying force, this question 21. So students, this is question 22, not 21. This question is 22, this one. This one is 22 and this one is 23, and 21 I am explaining here. Question 21. So why do camel or elephants have broad feet? Because, so we will write it, because the broader feet provide lesser pressure on the sand and it becomes easy for them means elephant or camel, to walk. Right? In the same way, students, you have seen horse. Here in the case of horse, area of it is less, so due to which the pressure is more, and hence the feet show a tendency to sink inside the sand, making it difficult for the horse to walk. So keep in mind the area, right? So now question 22. A sharp pin works better than a blunt pin. Explain the reason. Because on applying force, the sharp pin will exert more pressure as the area of contact is small. So sharp pin has this area. So this area of contact is small, so more pressure will be applied here while we push it, so it will become better. Question 23. Why is the bottom part of foundation of a building are made wider? Because the weight of building act on a larger area, hence will exert less pressure on the area would be larger, so it will exert less pressure on the ground, and it will avoid sinking of the building, right? So next we move on to question number 24. So what is it? It is easier to cut with a sharp knife than with a blunt one. Same, because the sharp knife has can be written here, has very small area, or not, or it is area of contact than the blunt one. So the pressure applied by force is more, and hence it is easier to cut with a sharp knife than a blunt one, right? Question 25. A gum boot rests on its base. If it is placed upside down, how does the thrust number second pressure will change? So a gum bottle has a narrow neck, as we know it has a narrow neck and broad base. So if it is placed upside down, so this is, if like play, this is gum bottle, if we place it like this is its mouth, right, inverted position, its surface, then its surface area, this surface area becomes less, due to which effect of thrust become larger. In the same way, surface area is less, this is area, hence the pressure becomes larger, right? So thrust will become here will become larger. In the same way, pressure would also become larger due to less surface area. This is area, right? Question 26. Explain the following. Sleepers are used below the rails. Because sleepers are used so that below the rails, rail tracks, so that the pressure exerted by the rails on the ground become less, right, due to broader area. So now a tall building has wide foundations, as explained earlier, because weight of the building act on larger area, and hence it will exert less pressure on the ground, and it will avoid sinking of the building. So students, to question 27, 28, 29, these are the activities on your page 47 and 48. For question 27, see activity 3, and for question 28, see activity 4, and for question 29, for C activity 5 and 6. So these 3 questions can be done straight away from your book. They are easy, right? Question 30. So these 3 questions has been explained here. Question 30. State 2 factors on which the pressure at a point in a liquid depends. So it depends upon the height of the liquid column. So because it increases with the height of the liquid column above the point, the pressure depends upon height of the liquid column, and it increases with the height of the liquid column, decreases with the shortness of the liquid column. Density of the liquid pressure increases with the increase in the density of the liquid, and decreases with the decrease in density of the liquid. Next, question 31. Describe an experiment. For this, see activity 7 on page 48 of your book. And for question 32, diagram 3.34 in your book explains the height. This is the 3.3. We have to tell what it explains or illustrates. So it explains or illustrates that the liquid pressure increases with the height of the liquid column. So pressure increases with the height of the liquid column, right? Here we are seeing a cylinder with two holes, right? Two holes, one near the top and one near the bottom, right? One near the bottom of the cylinder. These are closed with adhesive tape, right? And this is placed on a table and filled with water. Water is filled here. When we remove adhesive tapes from the holes, water coming out from the upper hole falls from here, it falls near the cylinder, and here it falls away from the cylinder, right? So what does this show? This shows that the liquid pressure at a point increases with the height of the liquid column above it, right? The more height, it will become nearer to the cylinder. So due to less pressure, the less height would show more pressure, right? So question number 33, describe an experiment to show that. This is the activity 8 on page 49 of your book. Question number 34, a dam has broader walls at the bottom than at the top. Give a reason. So the reason behind this is pressure at a point due to a liquid, just we have seen here, increases with the increase in the height column above it. So thickness of the wall of the dam is increased towards the bottom so as to withstand the increasing pressure of the water. So here pressure would be more, so thickness of the dam would be more. Wall of the dam, suppose this is the pressure, here wall would be become more broader, and here wall would be become less broader, right? So question number 35 is explained here. What do we mean by the atmospheric pressure? The atmospheric pressure is the thrust on unit per unit area of Earth's surface due to the column of air is called atmospheric pressure. Question number 36, write the numerical value of atmospheric pressure. So at the sea level on the Earth's surface, the atmospheric is 76 centimeter or 760 mm of mercury column, which is equal to 1 atmospheric or 1.013 into 10 raised to power. This is not 5, this 5 would be written here, 10 raised to power 5 pascals. Alright students, so now question number, this was question number 36 here. Now we will move on to question number 37 here. So why we don't feel easy even under the enormous atmospheric pressure? We don't feel uneasy under the enormous atmospheric pressure because the blood in veins our body also exerts a pressure which is called blood pressure, which is slightly higher than the atmospheric pressure. So this blood pressure makes the effect of atmospheric pressure null. So our body don't get ruptured due to this enormous atmospheric pressure, right? So this is gift of nature to us. Next is question number 38. Describe a simple experiment to illustrate that air exerts pressure. So for this, see activity 9, and for question 39, activity 10 or page 50, right? Now give reasons for the following is question number 40a. Explained here. A balloon collapses when air is removed from it because the pressure inside the balloon becomes lesser than that of pressure outside the balloon, so it gets collapsed. When pressure inside is less, pressure outside is more, it will become collapsed. Question B. Water does not run out of a dropper unless its rubber bulb is pressed because due to the atmospheric pressure water does not run out of a dropper unless its rubber bulb is pressed due to the atmospheric pressure from the outside, right? Next is C. Two holes are made in a sealed oil tin to take out oil from it because the atmospheric pressure acts on the oil due to air entering in the tin through one of the holes, and oil comes out of the tin through the other hole easily. When the air comes inside the tin by one hole, the atmospheric pressure will make it to move outside from the another hole easily. Question 41 is how does atmospheric pressure change with altitude? So the atmospheric pressure change with the altitude as it decreases with increasing altitude, or altitude is also called height, right? HEIGHT. Whenever we go higher above the earth's surface, the atmospheric pressure decreases, right students? So students, this is the numerical portion. It will be explained in the next video because our video has become lengthy, so you will get bored, but I have explained all the 41 questions, theoretical questions given in your book. And for this, thanks for watching this video. If you face any difficulty, then please move in comment section to solve your problem. Numericals of this section, this lesson will be explained in the next video. Till then, it's goodbye. Keep on watching our video. Revise your chapters, right, and study well to move forward. Understand the basic things to clear your concepts, right? And please make more and more shares, likes and subscriptions to our channel. Your comments, likes, subscriptions are a booster dose for us. Like COVID-19 booster dose is being applied these days. Hope you all must have taken the dose being provided at your schools. If not taken yet, then please take the dose. Thank you. It's goodbye for now.